we'll be continuing our look at series with geometric series, which is a series of repeated multiplication, and we're basically going to be adding up the terms of those. So the formulas are up, and the first formula here will give us the term in a specific geometric sequence, and the other two will be if we wanted to add up a part of that. Now notice the difference right here, n minus 1 and n right there. Okay, let's take a look at the first example. The question asks to write the formula for the geometric sequence and find the 15th term. So in order to do this, to do our formula, which is a sub n equals a sub 1, r, which is our common ratio, to the n minus 1, we need to know our first term, which in this case we do. It is 0.5. We need to know our rate, or our ratio, and I don't know that right away, but I can find it. And I can find my ratio by doing the second term divided by the first term, or any two, just so long as the term further along goes first. So I'm going to go ahead and do that, and I'll do 2 divided by 0.5, and I get a ratio of 4. So that means I'm multiplying by 4 each time. And n minus 1, a sub n. All right, so that gives us the formula. And then I want to find, according to this, the 15th term. So I will be replacing n with 15. So 15 minus 1 is 14. So I'll go ahead and type that in. So 0.5 times 4 to the 14th will give us this large number right here. Okay, so going on to the next one, same formula yet again. And our first term is 5. Our ratio, it looks like we're multiplying by -2 and n minus 1. So that gives us our formula. Now we want the 15th term, apparently. So this will be 14 yet again. And we'll type that in. And 81,920 is our answer for that one. And the last one, it looks like our rate. Now, if our rate or our ratio is difficult to find, we can just do the second term divided by the first term to get it. It's easy in this case, so 3. So a sub n is going to be 4, 3 to the n minus 1. Now, I do want to make a note of this, 4, 3 to the n minus 1. So when I go to do, now that's a sub n, I want a sub 15 next. Notice this would be wrong if I did 4, 3, 14, if I did 12 to the 14. Order of operations, guys. Exponents first. So that would be wrong right there. So we want to go ahead and put in 4 times 3 to the 14th. And we get this number. I won't bother writing it down, but the calculator is not doing 4 times 3 first. It's following the order of operations. It's doing the exponent first. Okay, let's take a look at the next one. So write an equation for the geometric sequence, but notice this time I don't know what the first term is in each of these. Now, I could count back from the ratio, but I think that's cumbersome. So what we're going to do is we're going to write our formula for the geometric sequence, which is this. And we'll go ahead and we know the 5th term. And the 5th term is 4. Now that means n is 5. So I know my rate's 3, n is 5. So we got 3 to the 4th right here. And we have a sub 1, and this is a 4. Now, 3 to the 4th is 81. And now I'll do divide by 81 to get that term. And it's just 4 over 81. So a sub 1 is 4 over 81. Now I'm ready to write my formula, which is going to be 4 over 81, my rate 3, and to the n minus 1, and there's my answer. So this one starts at the fourth term, so that means a sub 4 equals a sub 1 rate minus to the n minus 1, or a ratio. So the fourth term is 5. I don't know the first term. My ratio is 6, and to the n minus 1. Now n is 4, so 4 goes right there. So I'll have 5 equals a sub 1 to the times 6 to the third, and I'll be dividing by 6 to the third. So 5 divided by 6 to the third. And we get 5 over 216, or you could write the decimal right there and round it. I'll keep the fraction 5 over 216. So that's our first term. Our rate was 6, and to the n minus 1. And there's our answer. And this one's going to be similar, except our ratio is negative. So the third term is 16, which means n is 3. And it's going to be 3 minus 1, so we'll have a 2 right there. So we have 16 equals a sub 1 times 16, so a sub 1 is 1. So we have a to the n, or a sub n, equals 1 times negative 4 to the n minus 1. Okay, find the geometric means. So we have these two numbers at the end, and we want to know, well, what's coming in between. So we need to find our rate in order to, or our ratio in order to do this. So we'll go ahead and we'll say 2, 5, or 1,250 equals 2 r to the n minus 1. Now, this is the first term, second term, third term, fourth term, fifth term. So n is 5. So if n is 5, then 5 minus 1 is 4. I'll divide by 2 and get 625. And now I'll undo this by doing the fourth root. And we can type that in our calculator by doing the exponent 1 divided by 4. We can also use, some calculators have that key, in which case we could put a 4 right here, and on the inside do our 625. We'll get the same thing, 5. So our ratio is 5. Okay, so times 5 right here gives us 10. Times 5 gives us 50. Times 5 gives us 250. And just to verify, if I do 250 times 5, make sure we did it right. All right, 1,250, so that's good. Okay, it says find 4 geometric means between 0.5 and 512. So there's the setup. So we have, this is 1, 2, 3, 4, 5, 6. So this is the sixth term. So n equals 6. So 512 equals 0.5 times our ratio to the 6 minus 1. So 0.5, our ratio to the fifth. I'll divide by 0.5. And we get 1024. And we'll do the fifth root. And get 4 as our ratio. It's not our answer. We're going to times 4, so we'll get 2 right there, times 4. we'll get 8 times 4, we'll get 32 times 4, you get 128. Okay, so when you do this rooting, so I did the fifth root right here, you are not guaranteed to get a nice whole number. So you could get a decimal fraction, something like that, round appropriately, and then use that ratio. Okay, next thing is to find the sum, and our sum formulas, Sn, let's see, Sn, we could do the first term, and then from there, we could subtract the first term times the rate to the n, all over 1 minus the rate. Don't forget that 1 minus the rate. And we could also use this one, and we'll just use the one that is easiest for the situation that we have. Because in each one, we are given a different piece of information. So in this one, we want the last term, but we don't know what it is. But we do know it's n equals 10. Now, we could find that last term and use this formula right here. But I think it's easier just to use this one up here, that first one. So our first term minus our first term times our ratio. Well, our ratio is going to be the second term divided the first term. So in this case, 6 divided 2 is 3. So 3, and then 10 up there, and then 1 minus 3. So I'll just type all of that in. And that will give us the partial sum of that series, 59,048. There we go. Okay, now we could have used this second one if we basically did our other formula. A sub 10 would equal 2 times our rate of 3 to the n minus 1 to the 9. And then we would find our 10th one. So we could have done it that way. But in the end, it makes no difference. 39,366. And then I could, so now I have the 10th term. Now I could use this one with the stars next to it. But essentially they're the same. We have just basically accounted for our rate right here by the raising it to the nth power, or a ratio. Okay, so right here, we know the first term, we know our ratio, and we know the last term. So that's going to be that second formula. So we'll do our sum is going to be, we don't really care how many terms we have here. 125. Our ratio is a half, all divided by 1 minus a half. Okay, so I typed that in. Now I'll divide that by the quantity, 1 minus a half. And we get 3,875. Okay, this one. So we have some fractions going on here. So let's get our ratio. Our ratio will be 3 over 32 divided by 1/8. And we can keep flip change that. That's a 32. So our ratio is 3/4. Yeah, it looks good. Okay, so now I want the 17th term, so that's n equals 17. So I'll use that first formula. So our sum is going to be 1/8 minus 1/8. Then our rate, 3/4 to the n, so 17, all over 1 minus 3/4. We'll type that all in. A lot of fractions. 1/8 is 0.125. 3/4 is 0.75. You could type it all in with fractions. Then 1 minus 0.75. Okay, so we do get a fractional thing, so 0.496. All right, finishing up, we could have this notation here. Now, I'm going to jump ahead and take a look at this one. We don't necessarily need an n minus 1 here, because all the formula cares about is if we use this one anyway, if we use this formula, all we care about is the first and the last term and our ratio. So that this isn't an n minus 1 doesn't matter. So how do I know that these are geometric? Well, they have the same form as the geometric formula, which is this. Same general form. Okay, so let's find the first term here. 3 goes in, so a 2. So our first term will be 36. And our nth term, now I'm not going to use the 10 right there. I'm not going to use, well, I am going to use the 10 when I put it in, but I'm not going to, it's not necessarily the 10th term, right? It would be, how many terms do I have here? Well, I have 3. I would have 10 minus 3, 7, but one more because I count the first one. So I have 8 terms in this one. So if I listed them all out. So I'll have 4, 3, and then when I put in a 10 there for k, I get a 9. So let's go to the calculator. 4, 3 to the 9th. And that is 7, 8, 7, 3, 2. So if I want my sum, I can do 36 minus 7, 8, 7, 3, 2 times our ratio, which is 3, all over 1 minus 3. Put this all in. And down here will be a 2. Okay, so let's see. Was there a mistake somewhere? 1 minus our ratio, 3. Oh, there should be a negative 2. I typed that in wrong. 1 minus 3 is negative 2. So same answer, it just would be positive. So 11, 8, 11, 80, 80. Because that would be a negative, that's a negative. So there we go. Okay, this one, our first term is going to be 2/3, 4, to the, if I put in a 2, a 1. So that's going to be 8/3. And then our nth term. Now, how many terms do I have? Again, 9 minus 2 would be 7, and then one more, so 8. There are 8 terms right here. But I don't really care about that because I'm going to use this formula. Now, if I were using this other one, well, now I do care about how many terms I have. Now, if I use this second one, I actually don't need to find my nth term. So let's go ahead and try that. Let's not do it that way. Let's do this second formula. So our A is going to be, A1 is 8 over 3 minus 8 over 3. Our rate is 4, or ratio, I mean. And I know that because of that right there. And N, well, I just figured up there are 8 of them. And then 1 minus our rate, 3. So let's put that in. 8 divided by 3 minus 8 divided by 3. And just make this clear. That's its own thing. And then 4 to the 8. And then negative 3. And there we go. I'll get a decimal. So 58253. Okay, and the last one. So A1 is going to be 352, and that's 25 times 3, that's 75. And then let's go ahead and use that second formula again. So our sum will be 75 minus 75. Our rate is 5. And then n, well, let's see here. 6 minus 2 is 4. So one more than that gives us 5 terms. So there are 5 terms in this. And if you don't see that, it would be because I put in 2, I put in 3, I put in 4, I put in 5, I put in 6. See, 1, 2, 3, 4, 5 terms total right there. All right, all over. 1 minus 5. Okay, so 75, 75, 5, 5. 5 to the 5th, all over 1 minus 5. 58,575. All right, that wraps up this